kids. It's Mr. Krause here working with some Regents exams. Anybody else getting tired of doing Regents exams? Can't wait for summer? I'm with you, man. That's why we went into teaching. It's not about kids. It's not about math. It's about summer vacation. All right, man, just kidding. I wouldn't spend all this time doing these videos. I was going to love working with you guys. I'm not even working with you. I just feel like I am. So, disclaimer. If you're here to copy, turn me off now. I don't want you copying. I'm not here for you to copy. This is the New York State Algebra 2 Trig Regents exam. You will not pass this if you're just here to copy. Yeah, you might pass your course. Who cares? Have some pride. Have some pride in what you do. Turn this off. Go do your work and come back. If you're stuck, that's okay. Come back. Get some help. I'm going to tell you right now we're on August 2010. I've already done part 1, 1 through 14. This is part 1, 2 through, 14 through 27. So we'll go to page 6 and we will get started. Now, here's one of the things I want to say. I know that more than just my students are going to be using my videos. In fact, last time I did this, I had thousands of kids using my videos. Please, if you are using this, please subscribe. Check me out, subscribe. The more people I get subscribed, the more privileges I get on YouTube, and I'll be able to do some more special things. Also, if you should happen to get 100 on this Regents exam, and I've been teaching for 20 years. 20 years. That's a really long time. And in that time, I've taught a lot of course 1s and a lot of course 3s, a couple of them. Never have I once had a kid get 100 on a reading exam. I am so excited to get kids get 100 on a reading exam. So if you get one, I don't care what school district you come from or what school you come from, I want you to email me, kenkrause@gmail.com. It'll be in the show notes. I would like to hear from you. I'm going to post all of the kids that work through some of the stuff that I've done. If this helped you at all, please email me. I'm going to post your name up online. 100% Regents exam on course 3 Trig. All right? So anyway, let's get started, kids. Let's do this. I'll show you a couple different ways to do most problems. Again, I use the TI Inspire. Let me clear out. It is a great calculator. Very simple to use. I don't know what I just hit. Remember how I told you it was simple to use? I was lying. I was just clearing. And I'll clear this. I don't know sure why this is there. So we're going to clear it out. We're going to have that error. This is a TI Inspire. It's a great calculator to use. Please, if you have the opportunity to use it, please get it. Your school cannot stop you from using it. It is an amazing calculator. Very simple to use. So, what are the solutions of the following systems of equations? I'm going to do this quite honestly. I'm going to do this one algebraically. This one's graphically very simple to do. So 3x minus 6. So I'm going to go into graph mode. Ka-ching. See how there's other tabs here? Let's get rid of anybody else's crap. I don't like starting with people's crap on my computer. Turns out it's my crap, but anyway, we don't want that there. So the first one, I believe, let me turn my page here, is 3x. I don't know what I just did. Oh, there it is, 3x minus 6. So 3x minus 6. Do you know how I like to talk fast? I like to talk fast. If you don't like when I talk fast, rewind it. Slow it down. You can't slow it down, but you can at least try to figure out what I said. I want another graph, and I'm going to get another graph on this same one. I'll just hit the tab button. It's right here off to the right, and I'm going to do x squared minus x. So x squared minus x minus 6. Enter. All right, I have two solutions. It looks like I have one down here at like 0, 6 or 0, negative 6. And it looks like I have one here at maybe 4 something. Hard to see, so let me go to the table and take a look. That's even harder to see. Why is that so difficult to see? I don't understand why this can't be bigger. That's one thing. I wish I could see it. But anyway, let's go here. All we're looking for is when the y values are the same. So we're looking for, all right, let's just, I know how I can do this. Do this. Crunch these up a little bit. All right, that's how we're doing. So we're looking for the when the y value is the same. And look here, 4, 6, and 0, negative 6. That is the answers to our question. The x values are 0 and 4. Now, I can check them, but that's the answers. All right. Question here says, the roots of this are, in order to determine what the roots are, there's a couple things we could do. I could graph this. Let me show you how to graph this. We just did this. We'll graph it, 9x squared. Another graphing opportunity. Awesome. We don't want to save that. We're going to go back into graphing. And we're going to type in 9x squared, 9x squared plus 3x minus 4. And we'll hit graph. Now, wait a second. That's hard to see. I'll move that. Because it has two roots, it means it's not imaginary. And it looks like they're here and here. So we don't have, if it was equal roots, it would just have its little vertex on this axis. I just don't know if these are rational or irrational. It's impossible to tell. But at least I've narrowed down my choices. I know it's not imaginary. Just so you know, imaginary graphs would look something like this or something like this where it doesn't hit the x-axis. Real or equal roots would look something like this where it just touches it one time. So these two are hard to tell. Now the way we can determine this is, so now you're down to at least a 50-50 guess just by using the graphing calculator. But we need to tell by the discriminant. This is the easiest way to tell. And the discriminant, if you remember, is b squared, that's a b by the way, minus 4ac. B squared is 9, don't put 3 squared there, just put 9 minus 4 times 9 times negative 4. Now if you type that in your calculator, which I will about to do just to test my work, so I'll go over to calculator mode and I'll go 9 minus 4 times 9 times negative 4. Lots of kids forget that negative. Hit enter and you get 153. Since 153 is not a number that you can take the square root of very easily. If you take the square root of it, and here's another indicator of it, just take the square root of this, control square root of this number, you get an irrational number. And that tells you that the answers are going to be irrational. It will be rational if you get a number like 25 or 36 or 49 or 64, perfect squares. That's when it will be rational, but in this case it's irrational. Moving on. So we were given that A, B, C. Label it properly. This is little a, this is little b, little c. The hardest part about this is labeling it properly. A is 3, B is 5, C is 7. I want to find out what angle C is. Well, what we have here is side, side, side. I was not given a single angle, and you're not going to be able to do this using the law of sines if you're not given a single angle. So what I want to do is I want to write down the formula. Well, the formula will be c squared, little c, equals a squared plus b squared minus 2bc cosine 2. I just screwed that up. I apologize. 2ab cosine c. I don't like solving this for cosine c. It's not something I'd like to do. I want to get this all by itself, and hopefully by the time you've worked through my videos or in my class, you'll have figured this out. What we're going to do is we're going to take these two and move them over. Now that I've used this, let me just get some more room. Sorry, wrote too big. So what I'll end up with is c squared, and when I bring the a squared over, it's minus a squared minus b squared is equal to negative 2ab cosine c. Well, my goal is to still get cosine c by itself, so I'm going to divide by negative 2ab. Gone. So this is what cosine c is equal to. And that's what I'm going to substitute into. C was 7, so we'll put 7 squared, minus a, which is 3 squared, minus b, which is 5 squared, all over negative 2 times 3 times 5 is equal to cosine c. Now, again, kids, think about it. If you're going to look for an angle, every time you're going to look for an angle, you have to do inverse trig, cosine inverse, sine inverse, tangent inverse. I don't care what. You're going to be doing inverse trig. So let's get over to the calculator. We'll do control division, 7 squared minus, I have no idea what the other numbers were. Hold on. 3 squared minus 5 squared all over negative 2. I can't tell you how many kids forget the negative. Negative 2 times 3 times 5. Enter. Negative 1/2. We'll do the inverse cosine of that number, and we get 120 degrees. And there she is, kids. Your answer is 120 degrees. All right. So, wow, really difficult question. Let's think about what this looks like. This is x to the negative 1 minus 1 is divided by x minus 1. And the one thing you have to remember is this is the problem. You have to remember, if you have x to the negative 1, that's 1 over x. If you have x to the negative 2, that's 1 over x to the positive 2. X to the negative 3, that's 1 over x to the positive 3. So this thing really is 1 over x minus 1 over 1 all over. And I do these problems always the same way. It doesn't matter if they're this easy or not. X over 1 minus 1 over 1. Countless kids will cross this crap out and make me want to smack them across the head. You can't do that. You're not allowed to bust up a married pair. So you have to think about these things as being a married pair. They're married. You can't break them up. How do I solve these? I look at all their denominators and I find a common denominator. In this case, my common denominator is x. The lowest common denominator. And I'm going to multiply everything through by x. You'll see what I'm doing in a minute. It's beautiful. So let's see what I can cross off. I'll grab the black to cross off. This x cancels with this x. It leaves me 1 minus. Nothing cancels here, so 1 minus x. Notice no more fractions there. This leaves me x squared minus, these x's cancel, 1. Well, this can be factored to, I wish I could get rid of that line because that line's way too big. Remember, these are in parentheses. This is really 1 minus x over x plus 1, x minus 1. Now, hopefully your teacher did not screw you up and they taught you this stuff, that although these are not the same, they can be eliminated, but they make the negative 1. I like to call it the negative 1 rule. They're opposite. It only is true with the subtraction. So it's negative 1 over x plus 1. And I did not solve that correctly. Oh my goodness, I just made a huge mistake. Oh my gosh, let me come back. I want to apologize. I did a really bad thing. I'm going to do it right here. Let's fix it right here. So the numerator I was good with. That was 1 minus x. I was not bad with that. 1 minus x. And I just screwed up a little bit here. This is not x squared minus 1. Nothing cancels here. This is x and this is x. No, wait. That's where I made my mistake. I think I copied this over wrong. I am so sorry. Let me show you what this is equal to again. Fast forward. I'll try to get that out. All right, let's go back to this. So, this is 1 over x minus 1 over 1, x over 1 minus 1 over 1. My common denominator is x, so I'm going to multiply everything through by x. X and x and x. So in the numerator, let's see what I got. These x's cancel. That leaves me 1. Nothing cancels here, so that's minus x. The denominator, nothing cancels here, so I get x squared. And nothing cancels here, minus x. So remember, they're a married couple and you can't touch them. So in the numerator, I have 1 minus x. In the denominator, I'm going to take out a GCF of x, and I'm left with x minus 1. Now, you can cancel these. These aren't exactly the same. If they're exactly the same, I just cross them off, period. But when they're plus, it doesn't matter. But when one's a negative, when they're both negatives, you can cross them off, but they make the negative 1 rule. So it's negative 1 over x, which is the right answer. And hopefully, either I got rid of my mistakes that I made earlier and you didn't even know they happened, except until now, or you realize they made mistakes, accept my deepest apologies, and we'll move on. All right. It takes a crazy mind to get 100 on this Algebra 2 Regents exam. Really, it does. That's why I'm so excited if I get somebody that is able to do it. Send me your name. Send me your phone number. Not your phone number. I'm not calling you. Just send me your information. I'd love to hear from you. All right, let's talk about this. 3 over radical 3a squared b. The first thing I'm going to do is I'm going to simplify this. This is a perfect square. So I'm going to just take that right out. A square roots of 3b. Is that one of my answers? Heck no, because you're not really supposed to have radicals in the denominator. Why? I don't have a clue, nor do I care. Some mathematician a long time ago thought it was cool that we should not have it in that form. So we make you guys play around with it. Still don't know why. I probably should figure that out, but quite honestly, they're going to get rid of it anyway, so I don't really care that much. Let's get rid of it now, and let's see if we can find the right answer. So what we're going to do is we're going to multiply by this thing I want to get rid of. Radical 3b over radical 3b. Some of you are like, oh my God, this guy goes off on tangents so much I can't understand and I can't pay attention. Sorry, that's me. Get over it. Come on now. So what we're going to do is we'll multiply. Just multiply across. So you get 3 times the square root of 3b. All over. Now here's the hard part. The square root, if you have the square root of x times the square root of x, that's just x. The square root of 8 times the square root of 8, that's just 8. The square root of a pizza times the square root of a pizza, anybody want to guess? Oh yeah, it's equal to pizza. Now, if you can see the time, you'll see that it's 11 o'clock. Now you know why I'm talking about pizza. Getting a little hungry. So the square root of 3b times the square root of 3b is just 3b. So this is times 3b. We're almost done. Not quite finished yet. These 3's need to cancel. So I'm left with 3b over ab. Square root of 3b over ab, which is choice 3. Wow, Mr. Krause. Math is so much fun. Nope, not really. Not going to lie. Not really. One-to-one function. There it is right there. Bam. A one-to-one function passes the vertical line test and the horizontal line test. Passes why am I doing it in red or in green or in black? Passes the vertical, but does not pass the horizontal. This one passes the vertical and passes the horizontal. Looks like a promising choice. Passes the vertical. This one does not pass the horizontal line test because that's the one line I draw right there. I hit it over and over again. And this doesn't even pass the vertical line test. So choice 3 is your answer. Moving on to page 8. Wow, we are almost done. Not even close. We got a lot to go. And we got a lot to go before that Regents exam. So keep working hard, kids. Don't quit. The world does not need another quitter. We've got enough people with hands out looking for a freebie. We don't need any more. What we need is people working their butts off. And if you're that parent, if your parents are out there taking a free handout, you know what? Maybe they need it. Maybe they worked their entire life and maybe something happened. Maybe their business, maybe the business they were working through just shafted them out of a job. But you know what? I'll bet you look around and your mom and dad are desperately trying to find a job somewhere to help you out, to help themselves out, to help the family out. That's what you need to be doing. All right? You want to be the person driving the nice car, living in the house. You do not want to be the kid going, holy crap, I hope I have a job this week. Would you like fries with your burger? Please, sir, could I have $1? I need $1. No, you don't want to be that person. You want to be the person in the nice suit, in the nice clothes, going out to dinner, having a good time with your family, maybe taking a vacation once in a while. Tangents. Got to stop them. Two sides of a parallelogram are 10 centimeters and 18 centimeters. And one angle of the parallelogram is 46 degrees. So we'll take this as 46 degrees. Question says, what is the area of the parallelogram to the nearest centimeter? So I want to find its area. So if you look over in this formula sheet, the formula sheet's great. It gives you the wrong formula. But it's the only one they're going to give you. And it's this one way up here in the and they even give you two with a K. We love the K. K stands for Krause. So Krause is equal to 1/2 AB sine C. I'm not going to lie, that's a Krause. 1/2 ABs, that's for a triangle. So hopefully your teacher reminded you or told you at some point in your life that really I could break this parallelogram up into two triangles. One triangle here and one triangle here. And they're congruent, which means there's just two of them. So if you take this formula, K equals 1/2 AB times sine of C. And C is just the angle. A and B are the sides that make up that angle. And what I'm going to do with this thing, that's for a triangle. I'm just going to multiply by 2. Well, why would I go through multiplying by 1/2 and then multiply by 2? Let's just get rid of the half. I don't want half of it. I want the whole thing. So really, All I got to do is type that into my calculator. So 10 times 18 times the sine of 46. So 10 times 18. Yes, normally I would just put 180, but I don't want to confuse anybody. Times the sine of 46. Enter 129.48. There it is. There's our answer. Round to the nearest square centimeter. Boom, done. Thanks for coming. Make sure I don't make any mistakes. The minimum point of this graph of f of x is this. What is the minimum point? So whoa. We got to figure out. Let's pretend we know what our graph is. It's -1, -3. 1, 2, 3. Bam. Right there. That's the negative. That's the minimum point on our graph. And what we're going to do is we're going to take the function, we're going to add 5 to it. So you learned a couple of things. You learned that you could do a transformation up or down, or left or right. Okay, so let me just take you through a few ways they could ask this question. They could say, what is f of x plus 5? This actually is a move to the left 5. They could ask you f of x minus 5. I've seen this on the SAT a few times. That's a move to the right 5. But that's not what they're asking. They're putting the 5 on the outside. And if you remember correctly, this is a vertical shift up and down, and it's the normal way. So I want to move vertically up 5. So now my new point is going to be -1, +2. Ba-cham! There's my answer, kids. Oh my gosh. What is the product of these roots? Couldn't be any easier of a question than this. That is -1. That is 2. That is 3. Those are my roots. They multiply to give me -6. Done. Wow. How could they put that question on a test with some of these other crazy questions? Almost done with the multiple choice, kids. The conjugate. You have to remember, this is like being a married pair, and we want the conjugate of it. The conjugate of it is the exact same thing, but with a change of sign. Since this was a plus, this will be a minus. -2 minus 3i. You know what kids do on this question? They rush and select the wrong choice and don't get 100 on the Regents exam because of that. Not that that happened to me or anything. Not that I'm sad about that. When I want to get over being sad about a math question, I drink Brugger's coffee. Guys, if you don't know, I'm trying to get some endorsements from Brugger's. It's delicioso. All right, here we go. Moving on. What is the common difference of the geometric sequence whose first term is 27, whose fourth term is 30? What? Huh? All right. Things you got to remember. Geometric sequence. We're going to be multiplying by something. 1, 2, 3, 4. Fourth term. First one is 27. Second one is 64. All right. Now, I mathematically would do this a little bit differently than this, but quite frankly, I'm just going to cheat. First of all, pretty much guaranteed these two answers are not going to be it because they're freaking weird. Not going to lie, they're freaking weird. So we're going to try 3/4 and 4/3. Now, if I'm a smart person, and some of you are, if you multiply by 3/4, you should see that that's actually going to make the number smaller. But let me just show you this. Watch this. Let's hit clear. Let's get everything out of there. Watch this. This is going to be cool. I'm going to also teach you something about your calculator. Why did that happen? So let's try control menu and clear history. All right, so we're going to type in 27. Just hit enter. And we're going to take that times, see how it says answer, and we're going to multiply by 3/4. Control division 3/4. And it actually gets smaller. That's actually smaller. You just can't tell it. And if I just keep pressing enter, it just keeps getting smaller and smaller and smaller and smaller. But it certainly isn't going to go to me 64. So let's try pressing that 27 back in again. And I think the other one was 4/3. Yes, it is. So we're going to multiply by 4/3. Control division 4/3. And I'm going to press enter. Ah, it got bigger. I'm going to press enter again. Ah, it got bigger again. I'm going to press enter again. Ah, 64. Magic. We're done. 4/3 is the answer. And I told you it wasn't going to be one of those crazy answers. All right, which one represents the complete equation sine of 3x? One complete sine equal of 3 sine x. Okay, so let's see. First thing I need to know what the period is. The period is defined as 2 pi over b. And this is also one full cycle. One full cycle. So period is equal to 2 pi over. Now b is this thing in front of x. In this case, it's 3 pi. Well, notice the pi's are going to cancel. So I want my period to take 2 over 3. It should take a length of 2/3. So I could go from 0 over to 2/3. And I'm looking at my graphs, and not one of them goes from 0 to something. So the other thing I can do is start at the origin, and I can go 1/3 this way, and 1/3 this way, 1/3 this way, and 1/3 this way. So this one goes 1/3 this way, 1/3 this way. Does anything else? No, that goes 2/3. That goes pi over 3. See how they're trying to confuse you a little bit? But the period is 2/3, so I want to go 1/3 to the left. It has nothing to do with pi or not pi. It's just 1/3 to the right and 1/3 to the left. This was a tough question. Lots of kids I know must have missed this question. Very difficult question. Very easy, but very easy to miss too. So hopefully you understood that. 27 is the last problem of this section. Oh my gosh. Then we got to go to the multiple choice, the free response, and then we're done. Oh, which two functions are inverses of each other? So, inverses of each other, if you remember correctly, inverses of each other's are reflections over the line y equals x. So, I know the sine curve goes like this. And I know the cosine curve goes like this. Those do not look like reflections over the line y equals x. Not even remotely like it. I know y. This is a y-intercept of 3 and a slope of 8. This is a y-intercept of 3 and a slope of -8. Those are not reflections over the line y equals x. No, I don't have a clue. And maybe one of these two. I'm not sure. Let's try. I'm guessing it's 4. Let's just try. It's not 4. But I'm guessing it's 4. It's not 4. Just for fun. Let's calculate. So I believe 4 was 2x minus 4. So we'll graph. Ooh, got other people's crap in there. Don't like that. Just get a nice fresh graph every time. 2x minus 4. Hit enter. Okay. All right. And then hit tab. And then negative 1/2. Negative 1/2 is just negative 0.5x plus 4. Looking promising. Oh, man, they look kind of good. I mean, not bad. Let's just see. So what I want to do, maybe what I want to do is graph in the line y equals x, just so you see what it looks like. Oh, those don't look like reflections across, though. Does that look like this would have to be over here, right? That doesn't make any sense. It's not the right answer. So let's start over. Doesn't take long. And let's try e to the x. I think that's one of them. Enter. Ooh, that's funky. And let's hit tab, the natural log of x. Enter. Ah, that looks good. Let's hit tab. We'll look at x. And look at that. They look like exact mirror images of each other. So, kids, there it is. They are inverses. The other thing you can always tell is, notice that log and 10 to the x, natural log and e to the x, square root and squares, cube roots, they're all inverses of each other. You can look right there and see that. So there's my answer. It is choice 3. Don't want to erase. It is choice 3. Do you hear my dog barking upstairs? I have a little dog. She likes to bark at everything. It's annoying. Choice 3. All right. Hey, look. Hopefully you got most of these right. You're going to just keep plugging away. If you're struggling, keep working. It's going to get better. You will get much, much better at these. Just keep plugging away. Don't cheat. And if you like what you see, hit subscribe. We'll get those viewership ups. All right, kids. Peace out. Don't forget, if you get 100, send me an email, kenkrause@gmail.com. Peace out, sisters. I have no idea.